Today we are going to talk about momentum. Chances are you've heard momentum used before, and you've probably even used it when you've been talking about sports or an object that's moving. Any object that's moving, even a person, has momentum. Today our key question is going to be, what are some useful properties of momentum? More specifically, how can momentum apply to the bumper project that we just finished? Momentum is a property of moving matter. Any object that has momentum is moving. If an object is not moving, it cannot have any momentum. Momentum describes the tendency of objects to keep going in the same direction with the same speed. Changes in momentum result from forces or create forces. So if you're slowing an object down, you're changing its momentum, and you're slowing that object down with some sort of applied force. The momentum of a ball depends on its mass and velocity. Let's look at these balls below. So let's look at these two balls, ball A and ball B. Ball A has a mass of 1 kilogram and a velocity of 1 meter per second. Ball B has a mass of 1 kilogram and a velocity of 3 meters per second. So ball B is moving at a higher velocity than ball A. Therefore, ball B has more momentum than ball A. Because momentum is dependent on mass and velocity. Momentum and inertia. We've talked about inertia before with Newton's laws. Inertia is another property of mass that resists changes in velocity. However, inertia depends only on mass. Only on mass. Inertia is a scalar quantity, which means it does not include direction. There's my abbreviation for direction. Momentum is a property of moving mass that resists changes in a moving object's velocity. Momentum is a vector quantity, meaning momentum requires direction. So remember, inertia depends only on mass, but momentum depends on mass and velocity, and it requires direction. Let's look at another example involving momentum. In the diagram below, you have ball A and ball B. Ball A is a 1 kilogram ball moving at 1 meters per second. Ball B is 1 kilogram moving at 3 meters per second. A 1 Newton force is applied to deflect the motion of each ball. What happens? Would the force deflect both balls equally? Think about that. No, it would not deflect both balls equally. Ball B deflects much less than ball A when the same force is applied because ball B had a greater initial momentum. So ball B wanted to keep moving in the same direction a lot more than ball A did. Kinetic energy and momentum. In the next unit, we are going to learn all about kinetic energy. But it is important to know that kinetic energy and momentum are different quantities, even though they both depend on mass and speed. Kinetic energy is a scalar quantity, which, as we talked about earlier, that means it does not depend on direction. Momentum is a vector, so it always depends on direction. As you can see in the diagram below, you have two balls with the same mass moving at the same speed. They have the same kinetic energy, 2 joules, but their momentum is much different. Ball A has a momentum of -4, and ball B has a momentum of +4 because they're going in different directions. Momentum is a vector, so it always depends on direction. Now for the fun part, calculating momentum. The momentum of a moving object is equal to its mass multiplied by its velocity. So momentum is mass multiplied times its velocity. This means that momentum increases with both mass and velocity. Here is the equation for calculating momentum. The variable to stand for momentum is a p. Nobody truly understands why momentum is regarded as a p, but just remember momentum is p, okay? P equals mv. It kind of rhymes. So momentum equals mass times velocity. Mass multiplied by velocity. Let's practice by comparing momentum. A car is traveling at a velocity of 13.5 meters per second north on a straight road. The mass of the car is 1,300 kilograms. A motorcycle passes the car at a speed of 30 meters per second. The motorcycle with rider has a mass of 350 kilograms. Calculate and compare the momentum of the car and the motorcycle. So it's asking you to find momentum, and you are given the masses for both the car and the motorcycle, as well as the velocities for both the car and the motorcycle. It's asking you to calculate the momentum of the car and to calculate the momentum of the motorcycle. You're going to use your momentum equation, P equals mv. And first you're going to solve the momentum for the car. So in our word problem, we can see that the mass of the car was 1,300 kilograms and its velocity was 13.5 meters per second. So therefore, we are going to multiply 1,300 kilograms times 13.5 meters per second. When you put that into your calculator, you should get 17,550 kilogram meters per second. That is the unit for momentum. It sounds pretty weird, kilogram meters per second. Next, you're going to solve the momentum for the motorcycle. So we'll go back to our word problem. Notice that it told us the motorcycle's mass was 350 kilograms, and it was traveling at a velocity of 30 meters per second. Using our equation, P equals mv, we are going to do 350 kilograms times 30 meters per second. When you put that into your calculator, you'll get 10,500 kilogram meters per second. There's that weird unit again. So notice that the car has more momentum, even though it is going much slower. Momentum relies on both mass and velocity. Conservation of momentum. The law of conservation of momentum states when a system of interacting objects is not influenced by outside forces, such as friction, the total momentum of the system cannot change. So, if you were in space and you threw a rock forward from a skateboard, you would move backward in response because space does not have any friction. Or let's say if you were on a really icy sidewalk. If you were standing on a skateboard and you threw a rock forward, you would move backward in response because momentum must be conserved. Collisions in one dimension. A collision occurs when two or more objects hit each other. During a collision, momentum is transferred from one object to another. Collisions can be elastic or inelastic. An elastic collision is when balls would hit each other and then bounce off of each other. You might see this with a ball or cars. If cars hit each other and then kind of bounce off, that's an elastic collision. When you think elastic, think they bounce. An inelastic collision is when two objects hit each other and stick together. So after the collision, they would be stuck together and they would move off together in the same direction. So let's review the two types of collisions again. You have an elastic collision where objects bounce off of each other in the collision. Or you have an inelastic collision. The objects stick to each other after the collision. In both cases, momentum is still conserved. So the momentum that you had before the collision has to equal the momentum after the collision. Force is the rate of change of momentum. Momentum changes when a net force is applied. The opposite of this could also be true. If momentum changes, then forces are created. If momentum changes quickly, large forces are involved, as is in the case of a car accident. If a car goes from 60 miles per hour to 0 miles per hour, it takes a very large force to change the momentum of that car so quickly. Impulse. The product of a force and the time the force acts is called the impulse. Think of the egg demonstration in the video that we watched a couple weeks ago. Impulse is a way to measure a change in momentum because it is not always possible to calculate force and time individually since collisions happen so fast. Now you're going to practice calculating momentum. I will work the first problem for you, and then you're going to practice on your own to make sure that you know how to use the momentum equation correctly. Number 1, a 17-kilogram bowling ball moving at 12 meters per second down the lane. We're going to calculate the momentum of each of these problems. The first thing I do is I box out each number that the problem gives me. This ensures that I'm not going to get confused by all the words, and I can just focus on what the problem's giving me and what it's asking for. The next thing to do is to assign a variable to each number. So 17 kilograms is a mass. 12 meters per second would be velocity. Now I'm ready to solve for momentum. So the equation is P equals M times V. So that's equal to 17 times 12, which when you put that in your calculator equals 204. And then your unit is kilogram meters per second. Now you're ready to try the rest on your own. Be sure to turn them into the tray when you're finished.